In this video, I want to talk about using a two-way table to find marginal and conditional distributions. The first question should be, when do we actually use a two-way table? Well, we use a two-way table when we are dealing with two different types of categorical variables. For now, we'll just call them variable 1 and variable 2. So we put variable 1 in rows, variable 2 in columns, and then we fill in the corresponding information in the middle. Let's say we have two categorical variables. The first is clinically obese, which is a yes-no question. And then diabetes, yes and no. So as we're looking at people, we want to know, are they clinically obese and do they have diabetes? We start by putting our first variable in rows. So we have one for yes, clinically obese, and one for not clinically obese. Our second variable is columns for diabetes and no diabetes. Let's go ahead and draw a vertical line here. And we do have one extra row and one extra column. Sometimes these are not titled. Other times they are titled as total. So let's suppose we have 20 clinically obese patients that have diabetes, 10 clinically obese with no diabetes. So the total here would be 30. We have 20 not clinically obese patients that have diabetes, and 50 that are not clinically obese and no diabetes. So we have a total of 70 that are not clinically obese. We can see there are 40 that have diabetes and 60 without. In total, whether we add this row or this column, we can see we have 100 patients total. So here is my two-way table. Let's discuss marginal distributions and how to find them from our given two-way table. Marginal probability is defined to be the value in the margin, hence the name marginal probability, divided by the total number of observations. So let's go back to our two-way table that we formed earlier and look at the marginal distribution for obesity. Well, we have two things that could happen in obesity. They could be clinically obese or not clinically obese. So we have two probabilities that we need to find. For marginal probability, the numerator is the value in the margin, and that's what these total columns are. These are known as the margin. So for clinically obese, the number in the margin is 30, divided by the total number of observations, which is 100, or 0.3. For not clinically obese, the amount in the margin is 70, over the total number of observations, which is 100, so we have 0.7. So this is our marginal distribution for obesity. Next, let's find the marginal distribution for diabetes. There are two possible outcomes for diabetes, so once again, we have two probabilities that we need to find. This time, when we talk about the margin, we're going to talk about the bottom row. So for diabetes, we see that the margin is 40 over a total of 100 observations, or 0.4. For no diabetes, the margin is 60 over a total of 100 observations, gives us 0.6. Next, let's look at conditional distributions. In general, for conditional probability, we're going to look at the value in a given cell divided by the value in a given margin. The idea of conditional probabilities is that we already know something about our individual. So we have some kind of given condition that we already know is true. Hence the word conditional. We already have a condition on this particular individual. Let's look at our table and see if we can find some of these conditional probabilities. As an example of what this may look like, for individuals who are clinically obese, what is the probability they are diabetic? So we do have a condition. We are in particular looking at individuals who are clinically obese. So we already know this individual is clinically obese. When we want to find this probability, we want to know the probability they are diabetic. We then write a vertical bar, and then we write the condition that we already know. In this case, clinically obese. In order to find this probability, we said it was the value of a cell divided by the value of the margin. We know they're clinically obese, so my margin that I'm considering is this 30. The value of the cell, we want to know the chance they're diabetic. There are 20 diabetic in this particular row, or 0.667. So when we're doing these, this given condition restricts us to just one row or one column that we're considering. That will determine the margin, and then the value of the cell is the cell in that particular row or column. For a conditional distribution, it's comprised of all of our conditional probabilities. We've started by assuming we knew the person was clinically obese. What's the chance they're diabetic? Now let's suppose we know they're clinically obese. What's the chance they're not diabetic? Well, once again, I already know this patient is clinically obese. There are 10 of these patients that do not have diabetes out of a total of 30. So it would be 0.333. So this would be my conditional distribution for clinically obese. Let's do one more of these conditional distributions. I want to find the conditional distribution given that a patient has diabetes. So I know this patient has diabetes. So I'm considering this column right here. This is something that I already know. So what's the chance that they are clinically obese? Well, we have a total of 20 out of 40, or 0.5. What's the chance they're not clinically obese? Once again, we have 20 out of 40, or 0.5.